Hey everyone. So today's video, what we're going to be looking at is we're going to be having a look at how to find the distance from a line to a point. And you might say, well, it could be any number of things. It could be that, it could be that, it could be that. Like, what are we actually talking about? We're actually talking about the shortest distance from a line to a point. And if you think about it, the shortest distance from a point to a line has to be a perpendicular distance there. Okay, so that's what we're talking about. Some other things that we need to know is we also need, much like how when we defined the equation of a line, we also need a p0. We need a point, some point on the line, so that that can help us use the formula that I'm about to give you. And I'm not going to go through it, but that creates a right-angled triangle, which is and where the formula comes from, which uses the cross product, and that's where it all sort of comes together. But anyway, so the distance d that we're looking for, which will be how far, so this will be d in here, that distance d in there, how far is that line from the point, is equal to the following. So line AP naught, gee, my writing's pretty big there, isn't it? AP naught, so that vector from A to P naught, cross of the V, so the direction of the vector. So the magnitude of the cross product of those divided by the magnitude of vector v will give us our distance between a line and a point. Okay, so there's the formula. A is the point that we're given, that we've been asked to find the distance from. V is the direction vector of your line. And P naught is any point on the line. It can be any point, whether you're given a point or you have to find a point. That's how it works. Let's do an example. Okay. So let's have a look. So let's say find the distance between a point. Let's do -3, -1, and 2. And the line, let's do x plus 2 over -3, y minus 1 over 1, and z minus 3 over -2. So let's have a look at this and let's apply this formula here. So I'll push up a little bit. And here we go. So that is my point A here, okay? So that's my point A. We can find the position vector of that. And we're not, and this is my equation of my line here. And so we can get the direction vector from that. And so let's do that first. But we also need a P0. We haven't been given a point on the line, but we can find a point on the line, okay? So let's just write out what the parametrics are. And so let's say this is equal to T. So x is equal to -3t minus 2, y is equal to t plus 1, and z is equal to -2t plus 3. And so then our direction vector v is equal to -3i plus j minus 2. Okay, so just reading off from those values in there, okay? So there's my direction vector v. What else do I need? I need a. I've got over here, well, OA is going to be equal to -3i minus j plus 2k. So there's my OA. And I need a point. And so I haven't got one at the moment. So I'm just going to pick a point that's on this line. I'm just going to say when t is equal to 0, what's the point? And so t is equal to 0, I'm going to get x is equal to -2, y is equal to 1, and z is equal to 3. So there's my point. I'm going to take p naught as being -2, 1, 3. I know that is on the line, just substituting in t is equal to 0. And so therefore, my OP naught is equal to -2i plus j plus 3k. All right, and that will help me. I need to know AP naught. I haven't been writing my just in there. So AP naught is equal to P naught take away A. So this take away this will give me. Gee, that was going fast. A P naught is P naught take away A. So let's do that. Is equal to -2 take away -3. That's -2 plus 3. So that's just I. J take away -J is plus 2J. And 3K take away 2K is just K. And so AP naught is equal to that. So what have we got? So looking back at our formula, I've got AP naught, tick. I've got V, tick. I'm ready to sort of start doing this. My next step is to do the cross product of AP naught and V. Okay, so let's do this now. This takes a little bit of space. So AP naught, it's a bit harder on the computer, cross V is equal to, here we go. So I, J, K. So we've got our three-dimensional determinant here. And I've got 1, 2, 1. And V was, where is it? Over there. -3, 1, -2. Which is equal to I. Determinant of 2, 1, 1, -2. Take away J. And we're going to have 1, 1, -3, -2. Plus K. 1, 2, -3, 1. Okay, so I've just expanded out the determinant there, and let's just satisfy this one, equate this one. So -4 take away 1, that'll be -5i. J's, we've got -2, -2 take away -3, so -2 plus 3. So it's going to be +1, the determinant, so it's going to be -j. Just let me check that because I had multiple negatives going on there. -2 plus 3, +1j. Yep, that is correct. And k, it's going to be 1 plus 6, so that's going to be 7k. Okay, so there is my cross product, AP naught times V. Oh, and I probably just here, I probably shouldn't have done this because it's probably confusing to watch, but I probably shouldn't have put those magnitude ones in there because I'm sort of not ready. If I put magnitude, then it's magnitude around here, and it gets a bit messy. So I'll just go back and erase that and that. Okay, that just makes it a bit too much all in one go. Okay, so now I need the magnitude of this. So therefore, in fact, I could probably go straight to the answer now. I can probably go straight to my final working out. So I'm going to go distance is equal to magnitude of, there's my cross product. So -5i minus j plus 7k. So magnitude on the top line, that was that part there, and divide by a magnitude of v. So dividing by a magnitude of v, I'll just put there because I'm going to be doing this one anyway. Okay, so what have we got on the top line? We have 25 plus 1 plus 49. Let me just write that down. There's too many big numbers for my small brain. So 25 plus 1 plus 49. On the bottom line, it's the magnitude of V. And V was, where was it? V is right there, up there. That's going to be 9 plus 1 plus 4. Okay, and let's just satisfy that. So satisfy again, it's weird. So 49 plus 1 is 50. 50 plus 25, so that's going to be root 75 on the top line. On the bottom line, it's going to be root 14. Can we, we can just simplify this a little bit. 75 is 25 times 3, so that'll be 5 root 3 over 14. And that is my answer. There was no, this question didn't have any units in it, so it's just 5 root 3 over 14 units. And that is the distance between the point A and that line. Hopefully that made sense. See you in the next video.